As we begin Chapter 9, we're going to be looking at an assortment of different ideas. 9.1 is going to start with the idea of a sequence. So a mathematical sequence is a string of numbers that are connected somehow mathematically. So we're going to dig into all of this, different versions of this over the next few sections. But here's the first idea. So this formula here, based on n, is going to define for us this sequence. Now, when we get to calculus, there's going to be different choices. You don't have to always start with n as 1, but that's what we're going to be doing here, where n is going to represent the first number, and then the second number, then the third. So here's what I mean. So to define the sequence, we're going to say first n is 1, and we just put it into that equation. So negative 3 times 1 plus 8 gets us 5. Now we're going to do n is 2. Just plug that in for the n in the formula, and then we get 2. So this formula keeps generating for us the sequence. We move from n is 1 to 2 to 3, etc., and we generate this sequence. Now the sequence could go on indefinitely, but they just asked us for the first 5 terms. Okay, so let's try it ourselves now. So when n is 1, we're going to put in 5 times 1 minus 4, so we get 1. N is 2, we get 6. N is 3, we get 11. And there's our sequence, our first 5 terms. I could write it again here, but 1, 6, 11, 16, and 21. Okay, now we're going to eventually have to find the formula for this sequence ourselves. But one of the tricks they're pointing out here is that if we are hopping between an even and a positive and a negative number, one way in which we can see that is negative 1 to the n. So when n is an odd number, it's going to be negative. When n is an even, it's going to be positive. Okay, so let's crunch it here. We've got all of them set here. So this is going to create an alternation. So when n is 1, it's going to be a negative number. When n is 2, it's going to be positive. So odds will be negatives, evens will be positive. But the concept's the same. We're just plugging in 1 for n, crunching it down, and there's our sequence. Okay, now it's not negative 1 this time. The sequence required a 2, but we have the same concept. I have the negative into this power is going to make it alternate between positive and negative. So here's n is 1. So negative 2 to the first power is going to just be negative 2. So I've got 4 over negative 2. Okay, so let's try again. Now I have an even power, so this is now going to make this a positive number. So I've got 8 over 4. Whoops, sorry, that's 2. Now I'm just going to do one more. I think I have the answers here attached to this. Okay, so now we've got negative 2 to the odd power, so that's going to make it a negative. Okay, we could keep going there, but that's the idea. So the point is that we're oscillating between even and odd. All right, now if you remember, we saw this earlier in our college algebra studies here, that a piecewise function is just a function, excuse me, a function that is split up under different circumstances. It does different things. So let's take a look. We can have sequences that are piecewise as well. So if n is not divisible by 3, then we're going to square the number. If it is, we're going to divide by 3. So let's just take a look at it. So we have a piecewise statement. So here's n is 1. Okay, well, n is 1 is not divisible by 3, so we're following the top rule. So we're going to do 1 squared. When n is 2, it's not divisible by 3, we follow the top rule. Now, when we get to 3, however, 3 is divisible by 3, so we're going to follow the new bottom rule. 3 divided by 3 is 1. Okay, it goes on and on until we get again to 6, which is divisible by 3, moves us back to the bottom. So we just square things unless it's divisible by 3, and here's our sequence. Okay, we've got another piecewise here, so let's give it a shot. So n is 1. We've got, oh, so we have, yeah, odds and evens are our definition here. So I've got 2 times 1 to the third. So now n is 2, so we have an even number. So I've got 5 times 2 over 2. It's 5. Now n is 3, so we're back to an odd. So we're going back to the top rule. What is that? 54, right? I believe so. Yeah, and we can, in that way we keep going. So the next will be an even, so we'll move to the bottom rule, then we'll go to an odd, we'll go back to the top, and here's our sequence. Okay, now we're going to want to find the formula here. So they're saying, hey, can you find the pattern? This is a bit of a puzzle. So we'll talk through some of these. So the first thing I see with this first one is that I want it to alternate between positive and negative. So let's take a look at what they came up with and we can talk our way through. So the negative 1 to the nth is going to allow it to alternate between even and odd, or positive and negative. So I start with a negative, so negative 1 to the n times the, so remember we're starting with n as 1, so that'll work, that'll create the negative. And if 1 is my first number, then to generate that 2 on the top, I'm going to need 1 plus 1. I'm going to need n plus 1. Now the bottom would take some thought here. So we are starting with 11, but I keep changing by 2. So every time I keep generating a difference of 2, so I need to come up with something that would create that. And although this is a little clever here, what's really happening is 9 plus 2 times 1 would create 11. 9 plus 2 times 2 would create 13, and in that way I could keep generating that bottom number. Now, if we look at B here, we don't alternate between positive and negatives. It's always negatives. The top is always 2. What's happening on the bottom is that we keep squaring 5, or we keep raising 5 to a power. So we need our sequence to always be negative 2, so that part's fine. Now we don't, remember we start with n as 1, so if we just did 5 to the n, that wouldn't do it, because we need to get 25 for our first sequence. So we're going to do 5 to the n plus 1. That would generate 25. It would then generate 125, then 625, and we've got it. Okay, now look at this last one here. We have a sequence based on e. Now our first term is n equals 1, so we need e to something that gets us to 4. So n plus 3. So these are a little bit of a puzzle. The key is understanding, are you alternating between even and odds? What is staying stable in the sequence? And then how could I piece together what's changing based on the fact we start with n as 1? Okay, so here we've got a formula. We're starting at 9, and I'm noticing here that these are powers of 9. But what's different here is that this one is going to start with positive, then negative, positive, then negative. So look what we have to do to modify. This negative 1 to the n was what alternated between positive and negative for us, but we're going to make it negative 1 to the n plus 1. Do you see what that'll do is that will start us off with an even number. I keep saying that. Start us off with a positive, which is what we want. So negative 1 to the n is what we've been using, but that will create a negative to start with, and I don't want to start with a negative. But by adding 1, I can make this start with an even, or a positive. I'm sorry, it's early in the morning. Negative 1 to the n plus 1 will let me start with a positive number. Then we just have to generate powers of 9. So 9 to the 1, 9 to the 2, and etc. And we've got our sequence. Okay, let's try a couple more here. Now what I see here is on the top, I have powers of 3. Everything is also going to be a negative. So these are not going to oscillate. I don't need the negative 1 to the end. It's always going to be negatives. On the top, I have powers 3, so I'm going to start with 3 to the 1. So here's what I've got. So 3 to the 1, 3 to the 2, 3 to the 3. Now the bottom here, yeah, I was trying to see how they're doing that. Yeah, hold on. This is not correct what they did. It is, yeah, no, this is right on the bottom, but their top is wrong. I remember this. Okay, so this is what would generate the bottom. So on the top, we have powers. Yeah, mine is right. Theirs is off here. So we're getting powers of 3. So that is correct on the top. On the bottom, I've got 4. I've got the products of 4. I've basically got the multiplication table for 4. So 4 times 1, 4 times 2, 4 times 3. And that would be my sequence. I should put my a to the n on there. A sub n. Okay, so let's do another one here. I can see these are based on e. So I'm going to base this on e, but my first one is n to the 1, and we've got e to the 2 on the bottom. So try this. And again, it's hard to just define this for you. It's just a puzzle here. So if I do this, do you see this will move e to the bottom if you have a negative exponent? So if I start with 1, this is going to turn out to be e. Oh no, I don't have to put the negative. It'll do it itself. Yeah, never mind. So hold on. Just e to the n minus 3 will do it. So if I put in a 1, I get e to the negative second, which would move it down. I put in 2, I get e to the negative 1, which would move it down. Remember, negative e to the negative second is the same as 1 over e to the second. And the series will continue like that. Okay, there's an introduction to sequences. We're going to be spending some more time. They're going to get more complicated, of course. But so here what we were doing is just getting the basics of trying to define that mathematical sequence which creates it, or we were given what creates the sequence and we just needed to extend it to the first 5 or 6 terms.